Welcome back, students. Last time in the last module, we studied only half of the characteristics of stationary waves. Students, remember, in this module, we are going to continue studying the characteristics of stationary waves. So we move ahead, and in this module, the very first characteristic that we are going to study is the stationary wave. We can see that this wave has so many number of loops, and each loop is indicating that the wave is not moving. It is at that instant only, and that is why it is called a stationary wave. Now, to study this point, you can see I have this loop which is there, and I'm saying that the stationary wave is periodic in time. That means the stationary wave, you can see the animation, it is coming up and down, and it is repeating itself in equal intervals of time. Also, if you consider the space, the stationary waves is also periodic in space. That means you can see this length of the loop. Let me call this length of the loop as any x centimeter. You can see the very next loop also has the same length, that is x centimeter. So can I say that the next loop will also be x centimeter? It means the stationary wave keeps on repeating itself in equal interval of space as well as in the equal interval of time, and hence stationary waves is double periodic. It is periodic in time as well as in space. Moving ahead to the next point. In this point, we will see that there is this stationary wave which is formed by the incident of one incident wave, and then with the help of one rigid medium, there is a reflection of the wave, and there is a formation of stationary wave. We can see in the first loop, the particles are going up. In the second, the particles are coming down. If we see the animation, we'll see that this keeps on continuously happening. So I can say that the particles are not in the same state of vibration in both the adjacent loops. That means the particles are in the out of phase condition. That means particles are not vibrating in the in phase condition in the adjacent loops. They are in phase when they are in the same loop, but in the adjacent loops, they vibrate in opposite direction, meaning they vibrate out of phase. So, the point is that the particles in the adjacent loops always vibrate out of phase. We move ahead to the next point. In this point, we can see that there is an incident wave which is coming in. Now, the velocity of the incident wave is directed towards the right, and that of the reflected wave is directed towards the left. So we can say that one velocity is coming towards the right and other velocity is going towards the left. Velocity is a vector quantity. So can I say that the net velocity will be completely zero? Since one velocity is towards the right, the other velocity is towards the left, the net direction of the wave will be nowhere. That means the net velocity is zero, and hence such wave is called as stationary wave or standing wave, because it does not move. Hence it is called as the standing wave. That means there is no net energy transferred through the medium. That means there is no energy transfer taking place. We move ahead to the next point. In this point, we can see that the place where there is no displacement used to be called as the displacement node, but we can see it is also called as the pressure antinode. It means the place where there is minimum displacement. Can I say at that place there will be maximum variation in pressure? That means that point will be called as displacement node, since there is no displacement but maximum pressure, hence it will be called as pressure antinode. Similarly, moving ahead to the next point, which says that the point where there is displacement antinode, that means the particle can move freely, that point is displacement antinode. But can I say the pressure will be minimum? That is why the particle can move freely. So pressure is minimum, or the variation in pressure is minimum. Hence these points are also called as pressure nodes. So students, with the help of this module, we finally complete all the characteristics of stationary waves. Thank you.